So, before we start the next talk, which will apparently feature a lot of charts, I just wanted to announce that the closing ceremony will be in the Pirouette room, so in the other room, right after this talk, actually. And here we have Herbert Kohlmüller with radio interference structure and its security mechanism.
Yeah, thanks for introducing me. Since I haven't prepared that much, I thought it would be a good idea just to have some step back to that what I've heard this morning. So this is actually something similar what I've seen in the last, in the first two hours this day. And actually this is TEMS. So it's a monitoring tool for GSM, for 3G and for the LTE. And we are running this software, and we do, what do we do with that? We try at least to get the most out of the network, to get the best performance of the network, and that's we use that for. So to be honest, I'm from the operator side. I'm from A1 Telekom Austria, and I've got the honor to be the very last at this day, to be the very last of this 2 days, let's say, and it's not the last. Maybe it's some sort of beginning of the future. LTE, long-term evolution, is something that's going to be interesting for all operators right now. So the LTE the GSM story has more or less gone, I would say. So from operator side, the GSM is somehow treated as getting the money from it. With this perspective, it was very interesting to see for me these first 2 or maybe 4 hours today, that still there's some very interesting investigation done. And I fully agree with that. That this should be an ongoing process and still should be continued. Because there are for sure some security lacks, and that should be solved. And I was really very surprised that I see the signaling. So layer 3 is already decoded on the air interface. That's what we already see from the commercial tools, let's say. From commercial side, we just do logging on one mobile, but what I've learned today is that it is possible to trace any mobile, and that's going to be very interesting, and keep on doing that, I would say. Since I'm a radio engineer, I'm very interested, and maybe I'm gonna be one part of that story as well. I try to. Okay, that's gonna be my introduction. I'm in the field of radio optimization. I'm dealing with this layer 3, and so this is 2G. The main interest is 2G, but I'm looking, and I'm one of a few engineers at A1 Telekom Austria who are looking for the future for this LTE story, and that's gonna be what I want to present to you. And that's this LTE radio interface and its security mechanism. Since I'm not the security expert, I try to get somehow deeper in that subject, but I'm not the expert, I have to admit. I'm more the radio expert. So we will go through the content anyway. So it's more or less the basics. It's not the deep. Also the deep things are available. And let me take some comparison of the 2G, 3G and LTE network in the packet domain. So circuit domain seems to be something different, but as the LTE is packet only, from the beginning packet only, we just can compare the 2G, 3G and LTE in the packet domain basically from the beginning. And we have different namings for the BTSs or the base transceiver station. In 3G we call that node B, and in LTE, since it is somehow an evolved involved system, it's called involved node B. We've got some controlling station on the 2G side. We've got some controlling station on the 3G side, and that's hopefully an advantage. We haven't got that for the LTE side. So the controlling station has somehow moved to the eNode B, or let's say even to the serving gateway. And this gives us some advantages, since this RNC and the BSC, they need to do something that costs time, and we need to spare some time, since we want to get more throughput, we want to be more reactive, and we need to save some time. And for the 2G and 3G, we've got the serving GPRS node. It's called SGSN, and after that we've got, or maybe several of them, to carry all the traffic in the network. And we got the gateway GPRS support node, or let's say the GGSN, which is then the gateway to the World Wide Web. And we've got something similar in LTE, so nothing new, let's say, but well, definitely they compared to 3G, it's really somehow different. That we call that the core network, or to distinguish, the LTE is in reality the RF, let's say. So it's the RF, and it's not the core network. So the long-term evolution is in fact only this the radio part, and this involved packet core, is this core element, are these core elements, and the core elements, they consist of what we already know, so some mobility management entity, to get the handover up and running, or to see where's the mobile in idle mode, we get some, so this the connection to this eNode B is through some S1 interface, and the S1 interface can be distinguished between two. It's on the one hand the mobility management, and on the one hand it's the user traffic. And the user traffic goes through this serving gateway. So this is the serving gateway. There's a connection between those two, the mobility management entity and the serving gateway, and it's called the S11 interface. There's some sort like the VLR and the HLR, in the GSM and 3G world, and here it's called the home subscriber server, where all the quality of service and the keys maybe are stored in. And from this serving gateway with the S5 interface, we go to this public data network gateway, and then through that to the internet. Very interesting is that we've got the direct connection from one eNode B to the other eNode B. That could be really direct, but in most cases it's going to be a virtual interface. So it's not maybe a direct line or a real connection. It's a virtual interface. So the eNode B in practical manner is going to be connected to the mobility management entity or the serving gateway, through the S1, but over the S, which the serving gateway is more or less a router, and through this router function of the serving gateway, there's going to be some interchange. Let's say the X2 interface is going to be through this serving gateway. But in general, we speak of this X2 interface. The requirements from the next generation look like that. So it's going to be internet. The service is going to be internet. There should be some sort of telephony available. But it's basically then we will see what's going to happen. But it could be voice over IP. It could be some some old-fashioned circuit switched as well. There's some mobility, yeah, and maybe that's a big difference between all other systems, since all other systems, haven't got in the specs the mobility. Yeah, so this Wi-Fi or what else. Yeah, so there's some sort of mobility inside. Yeah, but the LTE requires up to 250 kilometers or even more. Yeah. There's some broadcast defined. Yeah, so you could run some television or what else. Yeah, or radio broadcast could be available as well. But I have strong doubts that this will ever happen, since the hardware is too expensive to provide these broadcast services. The data rates, current status is, we call that high data rates. Yeah, what's going to be happen in the future, I don't know. Yeah, but high data rates means currently now over the air interface up to 100 megabits in downlink. Maybe up to 300 megabits in the future. It depends on the structure of the antennas, yeah. And in uplink, up to 50 megabit per second, yeah. I mean, this, when I've seen that first in my life, yeah, that I was in a driving car, I've got the laptop beside me, yeah, and I've got 50 megabytes with a normal modem like a USB stick, yeah, and I've got 50 megabytes in the driving car, yeah. And I thought, oh, Herbert, that's going to be a new area. Yeah? That's going to be, I'm part of the future. Yeah, that's it was incredible. Yeah, me as a radio engineer, I could see 50 megabytes per second. Megabit per second, and that I thought, hey, you are in the future. Yeah, and what we are talking now is not the future; it's reality. Yeah, so that happens right now, yeah, and I mean, it's just a matter to deploy that out there. Yeah? So in some areas in Austria, let's say in Vienna, it's already working. I mean, we haven't got the SIM cards, we haven't got the modems, but it's already state of the art right now. Yeah? And it could be that maybe in 2 years, in 4 years, yeah, no one cares about this 2G or even 3G, because we are used to 100 of megabits in downlink. Yeah? I don't know what happens, but it's a very interesting subject. And what these radio engineers did, they tried to increase this spectral efficiency. Yeah, that's very interesting. And what leads them is, that they said, oh yes, this 3G with this wideband CDMA structure is not that efficient enough. Yeah. So we could go somehow one step further and use a different modulation scheme, and that's going to be, I talk about that later. And and the engineers thought, okay, this circuit switch data, or circuit switch connections, that's old-fashioned. Let's use the packet service only. And for this, they need some maybe user plane latency less than 10 milliseconds. That's what they defined, and the control plane latency less than 100 milliseconds, and that's now reality. Yeah, it's really incredible. Yeah, we do reach that right now. Yeah, and it's comparable to the fixed network in some stages. Yeah, so internally in our company there were some thoughts that maybe if hundreds of users use one cell, yeah, and they are doing download even with the half, with 50 megabit per second. So what's going to happen with the fixed lines? Yeah, because the traffic on the air interface has to be somehow covered by the fixed lines. Yeah, from the E node B down to some switching elements. And what I've seen so far is that even the hard disks, yeah, they are somehow on the limit to provide these data rates. Yeah. So very interesting. Even you need to get the data on the laptop, yeah. So the laptop, some interfaces, some USB interfaces are even not able to carry that traffic, yeah. So, and we had really, to be honest, we had to select the USB port, yeah, because not all USB ports are working for that speed, yeah. So some shared USB ports may be shared with some storages or like that. They are not capable of providing that speed. So it was a very interesting thing that the radio, the radio is that strong right now that on the fixed lines they haven't got, or even on the hardware they need to think somehow different. Some very interesting thoughts I got then. On the physical layer, I mentioned already they need to have some different sort of modulation, and in general it's a single frequency network, so all happens on one frequency. It's somehow comparable with this 3G story. So 3G uses only one frequency, or let's say one frequency band, and here we've got some single frequency network. So in downlink we use this orthogonal frequency division multiple access. Maybe I will provide some example to that. In uplink, something similar. So the processor is doing something similar. It's single carrier frequency division multiple access. You can look in Google to find these things. They're very interesting modulation, and we use already this orthogonal frequency division multiple access. So this the digital TV these days, and the Wi-Fi is using that already. So it's nothing new, and even the chipsets are already prepared. Maybe not for the frequency, we use that for this LTE, but for some different frequencies. The first handsets I've saw, they were very big. So the mobile stations were very big. They contained of that already existing Wi-Fi or what else. So the chips are already there. They need just to be brought to a smaller size. Maybe the energy consumption, maybe the frequency is different. Very interesting thing is that although all mobiles are on the same frequency, or the network is on one frequency, the bandwidth is scalable. So that's going to be very interesting for the operators. So they could start with on GSM 900 with maybe 1.4 megahertz, and provide still the old service for GSM if they've got enough bandwidth there. And they could extend to 3, to 5, to 10, to 20 megahertz. So what currently status is right now, all speed which are provided in the web regarding LTE, they are measured usually with 20 megahertz. You cannot say less than the maximum. New antenna technology. So MIMO, multiple in, multiple output, and this adaptive antenna systems. They are, So AAS maybe not, but MIMO is common. So all these new fashion LTE modems, they use MIMO. So they've got two receiving and two transmitting antenna inside. And that's state of the art. And in fact, in theory, you could double the throughput then. But that's theory. But anyway, it helps. It's a good approach for the technical to improve the throughput. What the technicians thought is they've got GSM, they've got the 3G, and 3G is quite complex. To be honest, it's too complex. From the operator side, I mean, from the operator technician side, it's too complex. This power regulation all the time, and it's really a very complex thing. And at the end, LTE is not that complex. So they really try to reduce the complexity of the system. So there's no BSC or even RNC. They're radio network controller, and this helps. But anyway, there needs to be some controlling. But this controlling has moved into these more intelligent eNote Bs or the MME. There's no soft or softer handover. So this was really some invention during 3G time, but it doesn't help. There's less protocol overhead, and it's somehow a self-organizing network. So my colleagues are somehow feared about that, because what we are doing is optimizing the network, finding out the best handover relations, finding out the best thresholds for certain situations. And if the network is self-organizing, it's doing it itself. So could be that maybe in 5 years I have to do something different. Yeah? So we will see what happens. Yeah? One important thing is the management, the mobility management entity. It's connected to the eNode B and doing this non-access stratum signaling. What does it mean? This is the bureau management. Yeah. So from the very first beginning, every customer gets a default bureau. Yeah. There's some quality of service control inside. Yeah. There's the paging procedure inside. Yeah. The idle state and the mobility management. Yeah. And the user tracking is inside there. Yeah? So the user tracking somehow just got a different name. Yeah? It's in 2G and 3G we got this location area, and now in LTE it's a different name. It's a tracking area, but could be roughly the same. Yeah? There's some signaling. Yeah, and this signaling, may be connected to other mobility management entity, signaling to the home subscriber server, signaling to the serving gateway and the serving GPRS node, let's say to the old system in case of doing a handover to 2G or 3G. There's security management as well, and that's the reason I thought MME would be a good starting point for that to mention. It's authentication and deciphering and integrity protection inside here. That's going to be done by the MME. Let's go back to this spectrum. It's called orthogonal frequency division multiple access. Yeah, I don't know. Maybe you see that. Yeah, so this is going to be a different color than this. Yeah, these arrows. Yeah. Every arrow should be one carrier frequency. Yeah? So we are using orthogonal frequencies in a spacing maybe of 15 kilohertz. Yeah? And every user gets a minimum of them. Yeah? So that can be dynamically changed. It can change every 500 milliseconds. The bandwidth is could be modified by the operator. Yeah? So it's from 1.4 to 20 megahertz. Yeah? So we've got some lower guard band and some upper guard band because the next operator going to be starting here with the lower guard band. Yeah? So there needs to be some guard band to distinguish the interference from each other. And there are pilots. Yeah? Inside the whole bandwidth there are some pilots. The pilot is to get the or to figure out the propagation. Yeah? So if someone knows the propagation, yeah, it's you can easily calculate the disturbance, yeah, and that's going to be done right now with these pilots. Even in GSM, we've got the BCCH who is transmitting, the time slot 0 who is transmitting always with full power. So you have some sort of reference, and that's going to be important for the mobile to have some sort of reference. There's going to be some DC subcarrier in the middle, yeah, where nothing is transmitted. Yeah, so this is going to be, some strange thing. If we see that on the frequency axis and on the time axis, yeah, we see that the users get definitely resource blocks, which I've drawn some resource block here, which consists of 12 subcarriers, having at least 180 kilohertz, and one of these resource blocks has got 7 symbols inside, and the duration is half a millisecond, and we've got this upper guard band and the lower guard band here. And as we see here, the user, this yellow user, is now having for 1 millisecond these 2 blocks, and another half a millisecond these 2 blocks, and then for some reason it gets more resource blocks. So every half a millisecond, or at least every millisecond, the user can get more resource blocks. And even if the user is doing a handover, yeah, because it's a single frequency network, if the user is doing a handover to another cell, yeah, it for sure will get another resource block, which means it gets somehow another frequency. Yeah? Compared to GSM, it's somehow similar. Yeah? So we've got some frequency. Let's say this is one GSM channel, this is another GSM channel. Yeah? The mobile is using 2 GSM channels, yeah? And but could use more. Yeah? Even if the quality of service allows him, he could use all resource blocks, all of the 20 megahertz. So it's just a matter of the quality of service the user gets. Yeah? And if he's in idle mode, yeah, he could use nothing. Yeah? And this is very dynamically, even in 1 milliseconds, that could change. Compared to the 3G world, yeah, 3G uses the whole bandwidth all the time. Yeah? And every user is on top of that bandwidth, uses the same bandwidth all the time. Yeah? We've got here the users distinguished by the frequencies. Yeah? And so it's somehow a good mixture between the 3G and the 2G. Yeah? Very interesting system. And yes, seems to work somehow. Regarding the user plane latency, yeah, these are just some figures. Yeah, they are not for sure exactly. Yeah, if the data arrives at the serving gateway, it needs somehow some processing. Yeah, it needs somehow yeah, traveling on the S1 interface to the eNode B. In the eNode B, some processing. Yeah, at least we have got some latency from above or around 5 milliseconds to 20 milliseconds. Yeah. That's going to be happened right now. There's some, yeah, inside the application. Yeah, if you consider upper layers, then yeah, there could be some application to yeah, some process to figure out some disturbed packets, some disturbed messages. Yeah. Yeah, the control plane latency compared to 3G. Yeah, on 3G we have got several states here, and that's not that complicated now in the LTE. In LTE we've got just 2 states. Yeah, even idle. Yeah, there's, to be honest, there's a third state. Yeah, disconnected or switch off. Yeah, but yeah, we've got idle, and we've got that it's doing something. Yeah, and yeah, this transition is very fast. Yeah. No, sorry, there's something wrong. Yeah, so I just copied that. Yeah, so it's definitely wrong. Yeah, it's RRC connected, yeah. And it's not registered. It's connected and doing something. It's transferring data. And yeah, this is much more faster than we've got right now. Yeah, for 3G. Yeah? You need to wait at least half a second. Yeah, roughly. Yeah, the data are coming through the pipe to your mobile. Yeah, that's quite a long story. Yeah, at least at the very first beginning. Yeah. I always complain about that, but my colleagues do not believe that it's too late for me. There are some IDs inside the LTE. Yeah. Yeah. In the network, you've got this PLMN ID, so nothing will change here. So that's already exists. Yeah. So what's going to be new is this involved packet service bearer ID. So there are some bearer. Yeah. We know already some interactive bearer, some background bearer or what else. Yeah. So and they all get some ID. We've got the network entities. I mean, that's nothing new. We know already the physical cell ID. We can trace that more or less. There's some tracking ID which consists, or in former times was this location area. And the EMI, the EMI is well known. This GUMI is some sort of MNC, MCC and MMEI. Nothing really new. Yeah, in the involved UTRAN, what is new here? Yeah, there's some sort of random value having 4 bits. Yeah, and all other things maybe are not that new. Yeah. In the user equipment, the IMSI, well known. Yeah, this TMC, TMSI. Yeah. The EMI, yeah, and this GUTI. Yeah. This keys in this LTE, well, it's somehow similar to the 3G story. Yeah? They maybe these engineers thought, how could they improve this key story or the ciphering or what else? Yeah, and they made yeah, the same approach for 3G, I would say. There's inside the USIM for authentication. There's some bits somehow or keys inside. Yeah, from that they are derived as CK and the IK. Yeah, and yeah, it seems, yeah, that it's somehow hierarchical, yeah, and even for this NAS, the non-access stratum, yeah, there's some keys, yeah, which can be generated. There are some keys for the eNode B, yeah, for the communication, the radio resource control, yeah. There's some encoded, yeah, and encoded. I don't know what's the INT right now, yeah, but it's in the spec anyway. Yeah, so it's somehow hierarchical. Yeah, so they think to implement more keys, it's going to be more safe. Yeah, I have some doubts about that. Yeah? It could be that just more processing power you need. Yeah, but maybe it's not safe enough. Yeah. Since this morning, I know it nothing is safe. Yeah. The purpose of this key separation, yeah, is distinguish the user traffic from signaling. Yeah? So the keys are stored in different locations, maybe not only in one location. They are stored in different locations. That could help anyway. Yeah? There's a renewal. Yeah? The key could change on the fly. Yeah? That's going to be implemented right now in the specs. You've got somehow some security which can vary. Yeah? So the operator can decide the level of the security, yeah? Even to use the key generation or even not use that. Yeah? And they want to have that more independence of the radio interface. Yeah? Currently there's 2 mandatory sets of security. This SNOW 3G and the FIPS 197. And the mobiles, they all should support that. Yeah? Even the eNode B and the MME, they should support these both sets of security. Yeah, the algorithm is negotiated separately between the UE and the eNode B, and even on the NAS level. Yeah, and the UE security capabilities sent in setup procedure algorithm. Yeah, and can only change during the handover. So the handover, yeah, during handover there could be some change in the security algorithm. Yeah. It's already defined in the specs. If it is gonna happen in reality, that the operator will decide to go for that, that's gonna be a question. Yeah. For voice over LTE, so I've just covered this packet story right now. Yeah, for voice over LTE, there's gonna be some discussions if they want to have some circuit switched fallback. Yeah, so some circuit switched pipe, which yeah, is gonna be introduced. At least they think about that. Yeah, personally, I think this IMS will be the story for the future, so every traffic will go through this IMS. Yeah, so it's already deployed out there in some companies, and yeah, this IMS is some strange thing for me as radio engineer, and it has for sure some lacks of security, and it's not the best one, I would say. Even some old-fashioned relay just would provide less latency than this IMS. So it's going to be somehow have to be improved in the future, this IMS story. This circuit switch fallback, what does that mean? It could mean that within the LTE there's some sort of circuit switched inside. It could well mean that if the LTE discovers that the user just wants to have circuit switch data, providing telephony, the call is handed over to 3G, or the call is handed over to 2G. Because of that, because maybe 2G needs some traffic, and the 2G is perfect for voice, and this LTE is perfect for data, maybe. Inside this subscriber authentication in the IMS, so there's a SIP layer authentication that's well known already, and some sort of access network bundle authentication, trusted node authentication. So there's some ongoing thing inside the IMS. So still some work to do inside the IMS. I thought, since I do not present something practically, so all my, at least in the morning lessons, they provided some practical. I thought I provide this, some flow, of registration of a mobile to see where for voice, where we can have unprotected access on the air interface. I mean, basically, I think it's nothing new, since this is somehow a sort of voice over IP, but there exists on the air interface some unprotected areas. For the future, then, there are some thoughts that you can buy some home eNote B. Even I heard that today these picocells, they're already available, and there's going to be some work on that, to get somehow deeply into this picocell story. So they are mainly using some unsecure network to the operator, and the operator itself provides some security gateway. And there needs to be some device authentication, and that's mandatory for this home eNote B, let's say. And I mean, it's going to be a question for the future if this home eNote B will come. I don't know if that's going to be some successor in the future. It could be, where if the operator doesn't provide any coverage, I build my coverage, myself, and that's going to be some strategy for the operators maybe to go this way. And there's this unsecure network. I mean, this is really unsecure. So everything happens, or everything what man can believe happens here. And for sure, this is some sort of security issue. Another thing they are thinking in LTE is to provide some relay node. They already think that for GSM, they think that for 3G, but I think the story for 2G, 3G is gone. But LTE is still alive, and it's still under study if that's going to happen, because it's a single frequency network. Everything happens on the same frequency. It could be that a mobile, I mean, not my one, but some other mobile could interact as a relay, and forwards the packet to the user, or vice versa, then to the real network. I don't know what if that really happens, because this relay node, that's going to be some security issue. And inside the relay node, that there can happen everything you can imagine. So basically, that was it. Yeah. If you want to if you want to contact me, just contact me. I'm keen to follow you. And thanks for your attention. If you have some questions, don't hesitate to ask.
Any questions?
I have a question regarding the diagram you show us. I've seen that the IPsec tunnel was terminating on the mobile device. I had the impression that they were terminated on the eNode B, that they were going from the eNode B to the gateway, but
you mean from the IPsec? Yeah, I know what you mean. Yeah. For example, this one here. From the eNode B to the serving gateway.
Yeah, but the question is the IPsec tunnel terminated on the user device or in the eNode B? Coming from the network.
Yeah, there exist different approaches. Yeah,
okay.
So it could be in the eNode B.
Mm-hmm.
That's going to be implemented right now. It could be well in the so maybe on higher layers then. Yeah, so the application requires some IPsec then on the user equipment. But it's definitely not easy because you're running this X2 interface, and with this X2 interface, this IPsec. So at the very first beginning, there are some sort of troubles. Yeah. Very interesting story.
Question regarding the voice part. If you're doing the full IMS treatment, this is going to be normal SIP. Is this the same layer 3 plane as normal internet connectivity going to be, or is this a separate subnet, VLAN, whatever kind of channel separation than the normal internet access? So can a normal smartphone, whatever, send from the application side, from the user configurable side, send zip packets to the IMS servers or not?
Yeah, good question. Yeah, but I believe it will happen like that. Yeah.
You will have a lot of fun there.
Yeah. So the radio part is just one tunnel, and all data are going through that. Yeah.
So there are no separate channels for different applications on lower level.
We do not call that PDB context. It's another bureau. Yeah. So you could have different bureau. Yeah. Maybe and all that in parallel. Yeah. So there could be a voice bureau. There could be some packet bureau. Yeah.
And on the handset side, if the phone calling features, the SIP features, are they going to be implemented on the baseband side of the phone or on the normal processor side of the phone? Do you have any ideas?
Sorry, no idea. Sorry. I mean, since it's not currently available right now, I have no idea about that. Sorry.
And just a remark about your questions. I think there are plans to have beer for signaling and for voice. So you have really for SIP a different one, different PDB context for signaling and for voice.
Yes, I agree. Yeah. There's for sure some signaling bureau. Yeah, there's for sure some. Yeah. So there are several bureaus defined already.
Yeah. And just a quick remark as well for the why there are two keys for RRC. There is one for encryption and one for integrity.
Yeah. Okay. This right. Yeah. It is. Yeah. So it's encryption. Yeah. ENC means encryption, and the other one is integrity protection. Yeah. All these things that were new for me, I've written down that here. So some
So,
questions.
I think that was the last one. Then thank you again.
Yep. Thank you.